This is Dr. Rajlakshmi, Professor of EC Department from Aditya Engineering College. Today we are going to discuss the module 1 of the course Integrated Circuits and Applications. In this module we are going to discuss the classification of integrated circuits by using various factors. The learning outcome of this module is the students can be able to learn the package types as well as the classification of ICs based on various factors, and those factors include, first one is we are going to see the classification based on the signal type and application. Now in the previous introduction session we discussed the importance of IC and its advantages, and coming to the basic what is the basic meaning of an IC. It's an integrated circuit whereby the active elements as well as the passive elements will be fabricated on a silicon area. So that is called an IC, and we already discussed the advantages and also some of the applications. And let us see the classification of ICs. So now first factor that we are going to discuss is IC classification based on the signal type. So first one, based on the input signal type. The input signal may be analog or digital or any kind of mixed signal. Now let us first discuss the first type of IC, that is called as digital IC. So we all know that digital IC is like a predefined package. It needs only the power supply, input and output sections. So no external circuitry is required for construction of the digital IC. It is a built-in package. So that's why there is no need of like stabilization of operating region characteristics. So it is not required in a digital IC. These are like easy to design, and these are produced as large quantities as low cost devices. The examples for digital ICs are microprocessor, that is IC 8255, microcontroller, that is IC 8051, and some of the commercial ICs are IC 74XX series, as well as the military applications that include the IC 54XX series. And comparator, 4-bit comparator is IC 7485. The second type of IC based on the input signal category is analog or linear IC. So here the output for this linear IC, the output is completely linearly proportional to the input. And here we require an external circuitry in order to be suitable, in order to make suitable for a particular application. So that's why operating region characteristics is stabilization is required for these linear ICs. And another advantage of this linear IC is we can amplify both AC signals as well as DC signals. The best example for this analog or linear IC is IC 741, which acts as a general purpose op-amp. Like it has varieties of it can be suitable for varieties of applications like addition, subtraction, integration, differentiation, amplification, buffer filtering, and in instrumentation systems everywhere. Like it is general purpose op-amp, but the external circuitry for this IC 741 will differ from application to application. And the special purpose op-amp linear IC is LM380, which is suitable for audio power application. And third one is general purpose voltage regulator, which is IC 723. And third type of signal under signal category is mixed signal IC. Like here we'll make use of digital ICs as well as analog ICs. These two are combined on a single silicon chip. These mixed signal ICs will process both analog as well as digital signals. And nowadays these mixed signal ICs are useful in these 3G, 4G and 5G smart mobiles, and all the like upgraded generation techniques. So in the communication techniques, these mixed ICs are generally used when compared to analog or digital ICs. And these are also used as a data converters that can be analog to digital or digital to analog conversion. And also these are used for local area networking as well as it's used in both LAN as well as WAN networking. So the second category which you are classifying the ICs are based on the packages. First type of package is flat top package. Flat package. Here you can, in the figure you can observe that there is a rectangular housing whereby the leads are exactly parallel to the rectangular housing. And these are parallel to the base plane on the opposite sides. And here the mains, the US military standard is Bill STD 1835C. That's defined as a flat package. And because of its structure, you can see that it cannot be easily fit into hardware. If we fit one side of the pins towards the board, breadboard, other will be on the top side. So it cannot be easily fit into hardware because it's difficult. It is suitable. It's not suitable for commercial applications. It is only suitable for military and aerospace applications. And this is available with 8, 4, 8, 10, 14 or 16 leads. And it's highly reliable, but the only thing is it's difficult to fit into hardware. So less preferred for commercial applications. So second type of IC package is metal can package. In the figure you can see the structure of metal can package. It is also called as transistor package because of its appearance of pins. And this here the designation for this metal can package is transistor outline 5. That's a standard metal semiconductor package. And here the commercial used silicon transistors for this transistor pack is 2N696 and 2N697. This has been manufactured by Fairchild Semiconductor. And here if you see the sealing, here it is completely hermetically sealed by using the metal lower in order to protect the device from environmental factors. And it's used in housing transistors with low lead counts, and it has 3 leads, and it also range from 5 to 12 leads. That is 5, 8, 10, 12 lead packages also exist. And the main application is it acts as a voltage regulator. LM117, which has 3 pins, and 5 pins it's suitable for audio power amplifiers. A third type of package, this dual inline package, it is a dual inline package, and this package can be easily fit into hardware because of its structure available here. You can see it in the figure. This is an 8-pin dual inline package. So 4 pins on one side and 4 pins on the other side. And here also these two pins are these two are parallel, and these are inexpensive and easy to handle. And because of its structure, it can be easily fit into hardware because the pins are exactly parallel and these are perpendicular to the rectangular housing. So because of its structure, it can be easily fit into hardware. All these 8 pins can be fit into hardware at a time. So space occupancy is good with this dual inline package compared to flat tap. And it's available with 8, 12, 14, 16 and 20 pins. And this 8-pin dual inline package is also called as mini DIP. And these are commonly used in computers and in all commercial laboratories. This dual inline package is preferred over flat top as well as transistor outline package. So this is the second category of IC classification that is based on packages. Third one is it is based on categorization or classification based on fabrication methods. First one is monolithic IC. Here you can see the monolithic IC, that as the term, it is a combination of two Greek words. One is mono and other is lithios. That is, here the active as well as passive elements are fabricated on a single silicon stone or chip. That's why it is called as monolithic, single stone. It is a combination of two Greek words. And the monolithic ICs can be bipolar or unipolar based on the type of the amplifier used in the circuit. And second category is a hybrid IC or multi-chip IC. Here in the hybrid IC, in order to fabricate this hybrid IC, multiple number of monolithic ICs are used. The best example of this is thin and thick film IC. In the figure, you can see the monolithic IC. And here for interconnecting all these elements, the passive and active elements, we are using the diffusion process and metallization process. And these are cheap, reliable, and thermally stable completely. And these are commercially used ICs for all applications like amplifiers, voltage regulators, AM receivers, and in computer circuits. But the main drawback in this monolithic IC is that the insulation between the components of monolithic IC is very poor. So its power rating is also very poor. So second type of IC based on the fabrication is hybrid IC or multi-chip IC. And here for this hybrid ICs, capacitors or inductors of large value are generally preferred. And here the active components used are the diffused transistors or diffusion diodes, and the passive components are diffuser resistors and diffused capacitors. And all these active and passive elements are connected by metallized patterns. And these hybrid ICs are generally suitable for high power applications, and unlike monolithic which are suitable for low power applications. And here if you observe the best example for hybrid IC, this is thin and thick film IC. Here you can see the resistors and capacitors are completely integrated, but the active elements are not at all integrated. They are kept as a separate components. When it as and when required, we will directly integrate it to the equipment. So that's why it is called a thin and thick film IC. So now we discussed the classification of IC based on signal type. Second one is based on packages. Third one is based on fabrication. And fourth one is based on the chip size. So chip size is nothing but the number of components used per chip. For example, if you are using 100 transistors or 3 to 30 gates per chip, it's stated as small scale integration. And for example, instead of using 100, if you use up to 1000 transistors or 30 to 300 gates per chip, it is medium scale integration. And if it's large scale integration, the transistors that you can equip are 1K to 10K or 300 to 3000 gates per chip can be equipped. Similarly, for VLSI, very large scale integration, 10K to 100K number of transistors can be used per chip, or 3000 to 30,000 gates per chip can be equipped. If it is ultra large scale, 10 power 5 to 10 power 6 transistors can be used, or 30,000 to 300,000 gates per chip can be equipped. So in the present era, like application oriented, we gradually the giant large scale integration has also, the invention is under process, where 10 power 6 to 10 power 7 number of transistors are used, or you can use 3 to 10 power 5 to 3 to 10 power 6 number of gates can be used per chip. And if you see the SSI, here you are using integrated resistors, diodes and BJTs. And our medium scale integration that's generally used for BJT elements are BJTs and enhancer MOSFETs. And in LSI, large scale integration MOSFETs are used. And in VLSI, 8-bit or 16-bit process can also be utilized. And similarly for ULSI, ultra large scale 20 process can be developed. And coming to the fifth category with which you are classifying the IC is based on the application. So general purpose applications, the best example is IC741, which can be used as an integrator, summer, subtractor, differentiator, averager, or you can say some instrumentational amplifier. So many applications are there for IC741. The only thing is the external circuit will change from application to application. So that's why it is called as general purpose application. And second type is special purpose application. So those linear ICs which are suitable for one particular application. That is, one of the example is LM380, which is suitable only for audio power applications.